Hello, once again, this is Mr. Wakefield, and we're going to be looking at section 6.4 here. In 6.4, we have two different things we're going to be doing. We're going to be dividing in both cases, but in the first case, we're just going to divide by a monomial, which, as we know, means one single term. Here, we're going to be divide by polynomials, and in particular, they're referring to when you divide by two or more terms. So you can see here in this problem right here underneath where it says polynomial by polynomial, we're dividing by two terms right there. That process is completely different than up here, which I'll show you in a minute. But on the back side, we'll be taking a look at what happens when we divide in particular by two terms. And that's going to involve long division. But don't use long division on the when you divide by a single term. Okay, that sometimes leads to some issues that we don't want. In particular, I want to mention, because sometimes when people do it the wrong way, they don't get the best possible looking answer that's completely simplified. So I do need to make a note here. No negative exponents in your answer. Sometimes, like I said, if people do it the other way with the long division, which you're only supposed to do when you divide by two terms, not just one term like this right here, you get some negative exponents. Not that that's the only way that you could get negative exponents, but the point is that if you do it the way I show you here, you should be just fine. So, how do we divide by a single term? Well, back in chapter 2, we kind of saw this briefly, not in as heavy detail, but when we had to get it into mx plus b form, we had two terms divided by a single term. And what we learned is that we had to split it apart. We're going to go over that again now, just with a bigger problem now, that's all. So just like when we had two terms on top right here and we ended up with two different fractions, it would make logical sense that since we have four terms on top here, we're going to end up with four fractions. All right. In other words, however many terms are in the thing that you're dividing into, the numerator, in other words, that's going to be the amount of fractions you get. Now, we got to divide each one of these things, just like we did in chapter 2, like I was just talking about. You got to divide each one of these by the term on the bottom, 5x. And what does that lead to? We need to be careful with our signs here as well. Just a reminder from what we talked about in chapter 2. When you have a positive answer, put a plus in front of the fraction, unless it's the first one, then you don't need to. You can if you want. It's not wrong. You just don't need to when it's the first one. If the first fraction it ended up being negative, which it will on the next problem, then you need to put the minus in front. But if it's plus, you don't. But you do need to have pluses or minuses in front of every fraction after that first one. Okay, so let's keep that in mind. So positive divided by positive is going to be positive. You could put a plus in front, but you don't have to since this is the first one. The next one is positive divided by positive. So since that's positive, I'm going to put a plus in front again. This is being careful with our signs here. Negative divided by positive is negative. So what you do is you do not ever put any negatives inside of your fractions in this problem. Just put the sign in front. Okay. So if it ends up being negative overall, negative divided by positive, for example, is negative, then you put a minus in front. Otherwise, you put a plus in front. But you don't end up with any negatives on the inside. Okay. That's the easiest way to do it. There we go. And then finally, negative divided by positive again here. So I'm going to put a minus in front. And again, no negatives on the inside. Then what you do at this point, just like we did in those chapter 2 problems, is you now take each fraction and you simplify it. And we do that just the same way we did in chapter 1. We did it at the beginning of this chapter as a review. Okay, where since you have a single fraction divided by a single fraction, you are allowed to just do the normal thing that you would do with a single fraction on the top and bottom, which is to reduce the coefficients. Get 5 over 1 right there if we divide both of those by 5. And we then take the variables. If they're the same letter, you subtract the exponents. and we put the bigger or we put the answer wherever the biggest exponent originally was. So x squared, 3 minus 1, all right, and then you put a 1 wherever the smaller exponent was. Okay. Do not ever cross cancel though right here, because you're only allowed to cross cancel when you are multiplying fractions. We are not multiplying these fractions, we're adding and subtracting them, as you can see. So stay within the same fraction when you cancel and put the fractions in lowest terms, okay? What do we got here on this first one? We got 5x squared over 1. So you could just say 5x squared. Bring down the plus, and we're on our way here. Let's do the next one. 50 and 5 is going to be 10 and 1. All right. And then 2 minus 1 on those exponents right there is going to be x to the first. And you put it where the bigger exponent was. Put the 1 where the smaller exponent was, like we said. So we end up with 10 times x over 1 times 1. That would be 10x. Bring down the minus. And next one. 40 and 5 reduced down to 8 and 1. The x and the x. Remember we said that when you have a single term on top and bottom, and the not only is the variable the same, x and x, but also the exponent, then they just cancel in the sense that you just say 1 over 1. Okay, they're exactly the same. We just say 1 over 1. The exponents are the same along with the letters x and x. All right, so what do we get there? We get 8 over 1, don't we? So we say 8. Bring down the minus. And then 10 and 2 10 and 5 cancel. We get 2 over 1. The x does not cancel because there's not another x above it. So we end up with 2 over x right there. Common mistake that students make is that if they end up with a fraction at the end here, they, for some reason, I've never figured out why a lot of students do this, but don't let yourself do this. Don't allow that fraction to go all the way across like this. I've seen students take this fraction bar and just extend it all the way. That's not correct, because you're supposed to realize that the denominator on each one of these fractions is equal to 1. That's why there's no denominator here on these. When the denominator is 1, you don't need a denominator. Okay, so if you extend that fraction bar all the way across here, you're going to be basically saying that the denominator for all of these is x. And that's not true. It's 1 for all of those other fractions besides the last one. All right. And there you go. So you split it up into different fractions. You put each fraction in lowest terms. That's basically the idea. Now here, on this next one, I just want to remind you, when you have a bracket divided by a bracket, okay, the brackets are telling you that it's like a fraction where the first fraction goes on the top. Pardon me, the first bracket, first bracket goes on top, and the second one goes on the bottom. Bracket divided by bracket, that's what that means. Okay, so now you can see that it's the same thing as this problem up here. We can just do it the same way. I just wanted you to realize that bracket divided by bracket means that, all right? So then what is this going to lead to? Positive divided by, and again, before I even do that, how many fractions are we going to have here? It all depends on how many of these terms there are. Because of the addition and subtraction here, this splits up into a total of 4 terms here, doesn't it? So we're going to have 4 fractions. Positive divided by negative on the first fraction is going to be negative, so I put the minus in front when it's negative. No minuses on the inside like we talked about. The next one's negative divided by negative, so that's going to be positive, so put the plus in front. Okay, when it's positive. Again, no negatives on the inside. Next one is positive divided by negative, so I'm going to put the minus in front. And then finish writing that fraction there. And then negative divided by negative is positive, so put the positive in front, or put the plus in front since it's positive, and then you now are ready to simplify or put these fractions, in other words, in lowest terms, all 4 of them. First one's going to be 5 over 1. And then you do 8 minus 5 on the exponents. That gives me x to the third, like that. And then, so what do we get there? We get negative 5x to the third as our first answer here. Bring down the plus right here. And let's do that again. 50 and 5 reduced down to 10 and 1. 7 minus 5 on the exponents right there gives me x to the second over 1. And so we end up with 10x squared over 1 on that one. Bring down the minus and we get, notice that 3 and the 5 don't cancel. That's okay. If they don't, they don't, all right? You got to just put it in lowest terms. But sometimes the coefficients are already in lowest terms, so leave it. Leave it that way. 6 minus 5 on the exponents, and we get x to the first over 1. And so we end up with what here? We end up with 3 times x over 5 times 1. 3 times x over 5 times 1. There you go right there. Okay. Bring down the plus. And then the last one is going to be 8 over 1 on the coefficients. And again, since the variable and the exponent are both the same, whenever that happens, when you have, assuming you have a single term on the top and bottom, one of those types of fractions, you then have 1 over 1 as what that becomes right there. All right, cancels out to be 1 over 1. So we end up with 8 times 1 over 1 times 1, and of course that is equal to 8 right there. And there you go. So please try problems 1 and 2 right now. You'll notice in 1 and 2, both of them have that bracket divided by bracket thing going on, just like in problem B. So just do exactly the same thing that I did right there. All right, you don't have to write down the step where it converts to a fraction. As long as you know that it's a fraction and you know what to do with the fraction, you don't have to actually write down the fraction. You can just jump right to the step right here where you've got the 4 fractions set up, okay, and then you can go ahead and simplify or put each fraction in lowest terms from there. Okay, so go ahead and give that a try and then press play after that. Okay, so then in number 1 right here, I went ahead and rewrote it as a fraction, even though you don't have to, all right? I just prefer to do it that way. It's a personal preference. And then realize that the minuses here separate the top into 3 terms. That means that we're going to have 3 fractions. And so let's take a look at those. Okay, since we got positive, negative, and positive when we divide right there, that's why you got positive here. You don't need to put the plus in front of the first one, and then minus and minus for the negatives, all right? Well, I then simplified those fractions, and I got 4x minus 2 over y minus 5 over xy squared, okay? Go ahead and show me how you canceled that as well. If you don't, I'm not going to make a huge deal out of it, but just for mainly for your own sake, I didn't put that there because I wanted you to be able to still see how I broke it apart. Those slash marks would have covered everything up. But yeah, the important thing is that you show these 2 steps right here. All right, but it would be recommended that you actually show the canceling out there for your own sake to make sure you're getting it right. In this problem number 2 over here, we got what? We got 4 fractions here because when I have this fraction right here that I set up after I changed it to a fraction, again, my personal preference, you can see here that the minus, the plus, and the minus here in the numerator means that we have 4 terms on the top. 4 terms on the top means 4 fractions. Okay, and then the 4 fractions, all right, simplify out to be what? Negative 9x to the third, and then you got the fraction right there because the 9 and the 2 don't cancel. All right, and then the last 2 terms right there. Okay, so that concludes our discussion on when you divide by a monomial. Okay, when we divide by, in other words, when your denominator is more than 1 term, like I said at the beginning of this discussion, that's a completely different method. But when you're just dividing by a single term down here, that's when we do what we just talked about here. Okay, so going back up here to the top of the page here, a reminder, when we do the long division right here, that is when we are dividing by what? More than 1 term, and in particular on the back side of the worksheet, it's going to be when we divide by 2 terms. All right, you cannot do what we just did with when you're dividing by 2 terms right here because let's say, for example, I had two terms down here. All right. The rule is that the denominator has to stay the same on all of these. So therefore, if let's say you had two terms down here, you wouldn't be able to cancel anything because you're not allowed to cancel a single term with two terms down here. All right. We talked about that in the earlier part of the chapter. A single term and two terms just does not work no matter what. So, the only way it could is if you were able to factor that denominator and get a single term out of that to cancel with the single term on the top. But that's not even gonna do a whole lot. And usually you can't even factor that denominator anyway. The point is that you need to do long division when you're dividing by two terms. Okay, so what is long division? We've talked about that, or you've talked about that in your previous math classes, I'm sure, ever since you were all the way back in elementary school. So what I'm going to do right now is look at one of your old elementary school problems real briefly off to the side here, just to kind of refresh your memory on some of the steps. And the steps aren't going to be exactly the same, but there will be some key similarities, though. Let's take a look at 86 divided by 3. 86 divided by 3... if I divide that, again, how does that done? You've always got to put the first one inside, and then the thing you're dividing by, the second one, goes outside. Then you have to do three things repeatedly. You have to divide first, meaning start out with the first number here, divide it by 3. In other words, how many times does 3 go into 8? Same thing. That would be 2, wouldn't it? Okay, so 8 divided by 3, it goes in 2 times. And then we multiply after we divide, don't we? 2 times 3. And then finally, after we divide and multiply, this last thing we do here is we subtract. And then after you bring down the 6 right there, the process repeats. Okay, you say, how many times does 3 go into 2? Well, it doesn't go into 2. But how many times does 3 go into 26? It goes in 8 times. And then we multiply after we divide. And again, after we divide and multiply, we then subtract. Okay. Now what we do, now that we're done with that process, we now take the 2 and the 3 together and we make it into a mixed number. Okay. Where the remainder goes on top and the thing on the outside here goes on the bottom. So it is 28 2/3, but one thing I want to remind you of, you guys, is that, and we're going to need to know this for the back side of the worksheet, when you have 28 2/3, say you have 28 2/3 apples inside of an apple bucket, okay, a bucket of apples, that means that you have 28 apples, complete total apples, plus 2/3 of another one. Now, I'm not claiming that you have to put a plus sign in a normal mixed number that you do. Okay, but whenever you do have a mixed number, there is an invisible plus sign in between the whole number 28 and the fraction. All right, we do need to take that invisible plus sign and we do need to make it visible in the problems we're about ready to do, because you're not allowed to have mixed numbers as they're normally written when variables are involved. I won't get into all the theory behind why that's true. Just understand that when you have variables involved, you can't write it in the normal mixed number form without that plus in there. All right. So officially, this answer would then be 28 plus 2/3. But because there's no variables here, it's okay to just say 28 2/3, like I wrote down up here. Okay. So the key thing I want you to remember is that it's those three things I said: divide, multiply, subtract, and then repeat. Okay. Again, there will be some differences, though. Watch out for those as I explain this, but those are the big three things that you're going to be doing. Now, as we said before, when you have a bracket divided by a bracket, that means that you are dividing the entire first bracket by the entire second one. What that means when you're doing long division, which we are going to do here, because the thing that you're dividing by Again, because there's a bracket here, you have to divide by the entire thing here, all right, not just the closest term, 2x, but by the whole thing. So, therefore, that proves that we are dividing by two terms and not just the 2x, but 2x plus 3. And so that's why we need to do long division, all right? We have to do the long division when we divide by two terms instead of just one. So we put the thing we're dividing by on the outside. The first thing, the thing we're dividing into, that goes on the inside of the division bar. Make sure, by the way, and this problem already is set up nicely for us in this regard, but make sure that the terms are in descending order from highest exponent down to lowest exponent. Okay, so you got x to the first and then no x at all. Here you got x to the third, x to the second, x to the first, and then no x at all. Make sure that the exponents go in descending order like that. Very important. All right, that's going to really be important as far as the overall process that we're going to do here. Okay, so divide, multiply, subtract, you guys. What's different about this problem, though, because we're dividing by two terms, is that I want you to just divide the first term here and the first term here. Let's write that down off to the side. 2x to the third divided by 2x. I want you to just put that in lowest terms, okay, which is the equivalent, at least for the moment, at least for this situation, that's the equivalent of dividing it. What would this be if we put it in lowest terms? Well, we just learned that on the front side of the worksheet, and not that we hadn't learned it even before that, but we just do the same thing when you got a single term divided by a single term. We end up getting 1x squared over 1, which is the same thing as x squared, all right? So, since that's what I got when I divided, I'm going to put that on the top, just like I did in that elementary school example I showed you earlier. What you get when you divide goes on top. Then you take, and I don't care where you put it, by the way, it doesn't matter. But then you take that answer and you multiply it by the entire outside. So the multiplication part, you got to multiply by the whole thing, not just the first term this time. Okay. What would I get if I did that? I would get 2x squared, 2x to the third, if I distribute that through, which is what you need to do, plus 3x squared. Now here's what you do. You take that, 2x to the third plus 3x squared, that answer, all right, and you bring it down here. And then this is where I kind of differ from the textbook, you guys. I like to subtract this entire line minus this entire line, okay? The textbook will just focus on the like terms only and leave the other terms alone. That causes a problem sometimes. I would just do the entire line here minus this entire line, minus the entire second line, in other words, in order to make sure that nothing gets left out or nothing gets confusing or whatnot. And so that's what I'm going to do. Please do that. And so remember, though, you guys, and let me go back to chapter 5 here for just a moment. Basically, when you got an entire polynomial minus an entire polynomial on the second line, that is the equivalent to section 5.1, which I'm looking at right now, where you have a bracket minus a bracket. I know you don't see any brackets here, but it's just equivalent to this, where we have to do the entire first line minus the entire second line. All right, so, but what did we do, you guys, when we had a bracket minus a bracket? We changed the signs of the second bracket while keeping the first one the same, right? First one the same, second one changes. So it's the same thing here. All right, the first line the first line does not change, just like the first bracket didn't change, but the second line does change. Each term does, just like the second bracket in those 5.1 problems. So positive, positive becomes negative, negative. And then what did we do after we changed the signs of each term in the second bracket? We combine like terms. Same thing here, you guys. Combine like terms. Okay? If I combine like terms, I get those cancel right there. Okay? This first column should always cancel, you guys. If it doesn't, something went wrong. That should always cancel when you get to this step where you combine like terms after you change the signs. What else is left? 10x squared And then the 9x and the minus 6 do not combine with anything. So as usual, when you're combining like terms and you have a couple terms that don't have any like term partners to combine with, just bring them down and add them to what's already there. Okay. Now that I have done the division and the multiplication and then the subtraction, which meant to change signs and combine like terms, I am now ready to repeat that process again. And so that means this, you guys. It means to take the first term again. Remember, we're on the division step. So you take the first term on the outside again, but this time we take the first term down here underneath the line that I made. All right, and we divide that. Let's take a look at that. 10x squared divided by 2x. What does that equal to if I do the normal canceling right there? Wouldn't it be equal to 5x to the first on the top with 1 times 1 on the bottom, which would be 5x? Okay. Since that is positive 5x, you got to say not just 5x here, but you got to say plus 5x. If it had been negative 5x, then you'd say minus 5x. But you got to have either a plus or minus in front of each term that goes after the first one there. Okay. And so that's why I put that plus up there with the 5x. Anyway, once we do the division, what did we do after the division in the previous part here? We multiplied the division result, 5x, by the entire outside polynomial, 2x plus 3. And what does that give me? That gives me 10x squared plus 15x when I distribute that out. Okay. So 10x squared plus 15x. But again, what did we say in the last problem here when we have to subtract now? You've got to change the signs of every term in the second line of terms here. All right, not the first line, but the second one. So positive term and positive term in the second line needs to change to what? It needs to change to negative, negative. Again, change the sign. All right, of whatever it is. So positive, positive becomes negative, negative. Then we combine like terms, and that means that these are going to cancel. 10 plus negative 10 is 0, so it cancels. 9 plus negative 15, all right, is going to be negative 6x. All right, and then the minus 6 doesn't combine with anything, so you just bring it down. So then what? Then we take the first term and the first term here, and we do it again. This is actually the last time that we're going to have to go through that cycle of divide, multiply, and subtract. I'll tell you why I know that when we get to the end here. Okay, there's a reason why we know when to stop. All right, and I'll tell you how you know when to stop. But anyway, what is this equal to? Well, the x's cancel completely, and we know that the negative 6 and the 2 are going to reduce down to negative 3 over 1. So since the x's cancel completely, the whole thing is just equal to negative 3. All right. Because it's negative 3, I'm going to write down minus 3 up there right behind the stuff that I already have up there. And then what? Then I am going to take negative 3. And I'm going to multiply by the outside part, just like I've been doing with my division answers. All right, if I distribute that through, I get negative 6x minus 9. Okay. And so I take negative 6x minus, minus 9. That's correct. Minus 9. And I bring that down right down below here. But remember, you need to change your signs before you combine like terms. But just the second line changes. So if it's negative, negative, it becomes what? It becomes positive, positive. And now when you combine like terms, once again, these change sign, or pardon me, they don't change signs, they cancel out, okay? And you're just left with 3 when you combine these. Okay, now how do I know that I'm done now? All right, let's go back to the front side of the worksheet for just a moment, okay? In the front side of the worksheet here, it says here when the degree of the remainder, which is that thing that's underneath the line, okay, each line here. So this is a remainder. It's not the final remainder, but it's a remainder. This is a remainder since it's underneath that line. And then this down here is a remainder as well. Okay. And so all three of those things are remainders, but what's the degree of this thing out here? This is a degree 1 polynomial because, as we've discussed before, when you have a polynomial, the term that has a highest degree, that number will be the degree of the entire polynomial. So since this is a degree 1 term, x to the first power, and this is a degree 0 term, because it's got no x at all, then this is a degree 1 term. The highest degree term tells you the degree of the whole thing. This right here, because of the x squared, is a degree 2 term. This right here is a degree 1 term. And so I need to keep on going until the degree of the remainder is a smaller degree than the degree on the outside. Okay, now look back over here now. You can see that the degree of this right here is degree 1, isn't it? Because of the x to the first power. All right. This right here is degree 2 because of the x to the second. I'm sorry, I looked at the wrong. No, I didn't. I actually did look at the right thing. It's right underneath the line, so I knew I was looking at the right thing. You look at that polynomial right underneath the line. That's your remainder. Not the final remainder, but a remainder. We'll get to the final remainder here in a second. This remainder right here underneath this line is degree 1 because it's x to the first power, and that's the highest degree term in this polynomial right here. But then this is what? This final remainder down here at the bottom is degree 0, and since that is finally a smaller degree than the degree of this thing on the outside here, which we call the divisor, that means we're finally done. So you got to keep on going until the degree of your remainder that you currently have is a smaller degree than this degree here. Now that we do have that, though, you guys, remember, just like when you make a mixed number, all right, you take your final remainder, you put it on top, you put the thing on the outside here underneath it, but like I said, you guys, when you have variables involved, you got to take that plus that's normally invisible when you do a mixed number, and you got to put it there. And that is your final answer there after you make that fraction. Okay? All right, let's try that one more time now. Problem D. We got to be a little bit more careful here in problem D just because there's some missing terms here. See how the x to the fourth is missing here and also the x to the first power is missing here? Okay, doesn't mean that anything's wrong there or it's too difficult to do. It just means that you got to be a little bit extra careful there. So let's write this down. X squared minus 2 will go on the outside because it's the second polynomial in the division process. And then we have 3x to the fifth minus x to the third plus 4x squared minus 12x and then minus 8. And so let's get the process started here with the normal division, multiply, subtract, that 3-part process that you continually repeat. What is 3x to the fifth divided by x squared? Let me write that down up here at the top so I have enough room to do all this. Okay, as I work my way down. This is going to be equal to, if you do your normal canceling here, it's going to be 3x to the third. And so we do what? We take 3x to the third. We put it up here. Again, it doesn't matter where. I prefer to put it kind of over to the left here just so I have enough room to put the entire answer eventually. And then what? Then I take the 3x to the third and then I multiply by the outside part, just like we did in the last problem. Multiply by the entire thing. You got to put that in parentheses, you guys, that outside part, because again, it's got two terms and you're multiplying it by something. That's an automatic thing where you got to bracket those two terms if you're multiplying both terms by something, and you are, because you got to multiply the whole thing, not just one of those terms, the whole thing. What do we get if I distribute that out? 3x to the fifth minus 6x to the third. And so I take 3x to the fifth minus 6x to the third, and I bring that down, but I got to change signs of that second line before I combine like terms. And so that gives me negative here instead of positive, and then this one becomes positive because it was originally negative. Then we combine like terms. The first column, as it should always do, it cancels. We then get negative 1x to the third plus 6x to the third. And that's 5x to the third. And then the other terms don't combine with anything, so we just add those to whatever's there. Again, keep these in descending order. x3, x2, x1, and then no x at all, like that. Very important again. And then we got to do what? Then we got to do x squared and 5x to the third. We divide that. And that's going to end up being 5x when you do the normal reducing to lowest terms. Since that's positive 5x, I'm going to bring that up. Okay. And you got to say plus when it's positive. Then I take the 5x, which is the answer from the division, and I have to multiply that by the outside part right there. Put it in brackets again, the outside part, I mean. And then we get this right here. So 5x to the third minus 10x. Now, this is where it's tricky, you guys. All right. Notice that these are not like terms right here. These two right here that I'm pointing at, those are the like terms. Not that you're supposed to combine like terms until you change signs, but I'm just giving you a heads up right there. So this is positive and negative, right? So changing signs, we get negative and positive like that. I then combine like terms, those cancel. And then 4x squared does not have a like term partner right there. Okay, and so you just bring him down. Remember, bring down the highest degree term first. That's why I brought that one down now. And then these two right here are going to become negative 2x when you combine those. Okay, and then minus 8. Doesn't combine with anything, so bring that down. We're almost there, you guys. And notice, please, that this is a degree 2 remainder right here. And this entire thing up here is also degree 2. So we just need the remainder to be less than degree 2. So it looks like maybe one more time around here, dividing, multiplying, and subtracting. Let's see what happens. 4x squared divided by x squared is going to be 4, because the x squared is canceled completely. Since it's positive 4, I put plus 4 up here. All right. And then I take that 4 and I multiply that by the outside part right there. Distribute that through and we get 4x squared minus 8. Remember to change the signs of this. Change the signs of the second line before you combine like terms. And notice that not only do the 4x squared terms cancel, but so do these two, don't they? Minus 8 and plus 8, that's equal to 0 when you add those together as well. So all we have left is minus 2x. Okay, now, what does that mean for the answer? And by the way, why am I done? Why do I not have to go another cycle of dividing, multiplying, and subtracting? It's because this is degree 1, because it's just x to the first, and this is degree 2. So when the degree is less down here in the remainder, you know that you're done. So I take the remainder, I put it on top, and I put the thing that's on the outside of the division bar over here, and I put it underneath that. By the way, before I circle this answer, yes, you can change this to minus 2x instead of plus negative 2x, but you're only allowed to do that if this is a single term. Okay, if that had been more than one term right there, you wouldn't be able to just pull that minus out and change this to minus 2x. Okay. But you could if you want. So if you wanted to say minus and then just 2x here, that's okay. But you don't have to. You could keep it like this. You can just keep on doing the plus each time and then just put the entire remainder in the numerator there, including any negative signs that the remainder contains. All right, that's perfectly fine. All right, so this is problem C and D right here. All right, I've got 3 problems for you underneath there. By the way, one of those 3 problems underneath here is going to have a remainder of 0. When you have a remainder of 0, you don't need to write the fraction, because 0 divided by a non-zero thing on the bottom is just like adding 0, a 0 fraction. And anytime you add 0, it doesn't need to be written. So 0, if it's a 0 remainder, you don't need to write the fraction part, just to give you a heads up on that as well. All right, so please try those 3 problems, all right, and then hit your play button when you're done. Okay, so in number 3, you guys, let me zoom in there a little bit. There we go. In number 3, again, the x minus 3 goes on the outside. The numerator goes on the inside, because when you have a fraction, again, the numerator, it's just like when you have a bracket divided by a bracket, all right? The first thing goes on the inside, the second thing goes on the outside. So then what do? We take x to the third divided by x, and that is equal to what? That is going to be equal to x squared, and that's why you put positive x squared on the top there. We then multiply the x squared by the entire outside. We distribute it through the x and the 3 here, and we get we actually get x to the third minus 3x squared, all right? But I already changed the signs after that, so yes, it would be x to the third positive and then minus 3x squared, but then it changes signs after that. All right, so that's why you see what you see there. All right, then I combine like terms, and these cancel, don't they? X to the third and x to the third, and so combining like terms, I get x squared, and then the other 2 terms just come down. All right, then we start the process all over again. I've got to take x squared divided by x, the first term and the first term. What is x squared divided by x? That is equal to positive x to the first. All right, if you were to divide those in the normal way. So I put plus x up here. I then multiply positive x by these 2 terms here, distribute it through there, and it gives me x squared minus 3x. X squared minus 3x, multiplying by positive x there. Okay, so x squared minus 3x, however, as I come down here, is going to be changing to negative x squared plus 3x. You got to change the sign of both of those. And so that's why I wrote down what you see there. All right, with those signs and everything. The x squared and the negative x squared then cancel, as they should, and we end up with 8x minus 3 when I combine like terms. Okay. Now, then we do 8x, the first term here, divided by the first term there. 8x divided by x, and that's going to be equal to positive 8. Positive 8. So then I put plus 8 up there since it's positive, and then I distribute the 8 through these 2 terms, and I get, normally I would get 8x minus 24. 8x minus 24, but because I got to change the signs before I combine like terms, I then wrote down here negative 8x plus 24. I then combine like terms after I change those signs, and I get a final remainder of 21, and I know it's the final remainder because the degree of that remainder is 0, since there's no variable in it, and that's a smaller degree than this is up here in this divisor out here outside the division bar. Okay, so I know I'm done, so then I put the remainder on top, and I put this thing out here on the outside. I put that on the bottom, okay, with the plus before that, like you're supposed to do in these problems, the plus before the fraction. All right, and that's number 3. All right, now number 4 is again, you got to put the what? You got to put the top here inside of the division bar and the bottom outside. Okay, so I don't want to give away the answer just yet, so let me show you that like this. Okay, and then what do we do once again? We do the first term here divided by the first term there, x squared divided by x. As you now know, we did it in the last problem, that's equal to positive x, so I just write down x at the top right there to start it off, and then I distribute that answer x through here. That would be x squared minus 5x. Okay, x squared minus 5x. X squared minus 5x, when you change the signs, is going to be equal to this right here, though, isn't it? After I change the signs, I combine like terms. The x squareds are going to cancel. And then combining the rest of it, I get negative 2x plus 10. Okay. And so this is a degree 1 polynomial right here. Due to the fact this is a degree 1 polynomial right here, right underneath this line, okay, this one right here, because of the x to the first. So I still have to keep going because this outside part right here is degree 1. And so if this is degree 1, you're not done yet. It's got to be a smaller degree on your remainder underneath the line. All right, so we keep going here. Negative 2x divided by x is going to be negative 2 only because negative 2, because there's no, the x's cancel completely, so there's just going to be negative 2 with no variable there. We then take negative 2 and we distribute that through here. And again, normally, you guys, that would be negative 2x plus 10. Negative 2x plus 10 when I distribute the negative 2. But I change the signs of both of those terms in that answer, and I get positive 2x minus 10. What happens, though, when I combine like terms right here? What happens is that everything cancels, doesn't it? Everything cancels there, all right? All 4 terms do, and when everything cancels while you're combining like terms, the answer is 0. That's always true, all right, when you combine like terms and all the terms cancel. Okay, so obviously since there's no variable here, this is a degree 0 polynomial, and so we're done because degree 0 is less than this one right here, which is degree 1. But not only that, though, but since the remainder actually is the number 0 with no variable or anything, it's just 0 only, then that means, like I mentioned just a few minutes ago, that means that the answer does not have that fraction in it that you would normally put in there. All right, so just circle what you already have when you get a remainder of 0, because you're not supposed to put that final fraction in there when the remainder is 0. If the remainder is anything other than 0, that's different. Okay. And finally, in number 5, we have this bigger one right here. Let me move it over. This bigger one right here where you've got a term missing here, don't you? All right, again, not to be alarmed by that, but just be careful when you're combining like terms and all that. The x term is missing here, but also the x to the first term is missing down here as well. So let's just keep that in mind to be careful there. So now, if I started off here, I need to do the first term here divided by the first term here. 15x to the 4th divided by 3x squared. If you put that in lowest terms like we were doing earlier, that would be 5x to the 2nd. I then take 5x to the 2nd and distribute it through here. That would be 15x to the 4th minus 5x squared. 15x to the 4th minus 5x squared, but I need to change the sign of both of those terms, and so I get negative 15x to the 4th plus 5x squared. That then leads to these two terms canceling right here, and combining the rest of the terms, we get 3x to the 3rd. Hey, you notice I paused right there. I got fooled by that, you guys. That's why I'm so concerned about that. Notice that these are not like terms. I wanted to combine those. So I was about ready to say 8 right there. Okay, but I stopped myself because those are not what? Those are not like terms. What is the like terms here? It's the 4 and the 5, aren't they? Okay, so 3x to the 3rd just comes down because he doesn't have anything to combine with, so you just bring him down if he's the first term, which he needs to be, because after you cancel the x to the 4th, so that would be the next biggest exponent, wouldn't it? So that's got to go first. Then you combine these two, and you get 9x squared, and then the plus 4 doesn't combine with anything. Let's keep going here. 3x to the 3rd has to get divided by 3x squared. If you divide by 3x squared, you get just plus x right there. All right, the 3's cancel. And so then we multiply x times this entire outside part here, distribute it through that, and we get what? We get 3x to the 3rd minus x. 3x to the 3rd minus x. Okay, and but remember, we got to change the signs of those. So 3x to the 3rd minus x becomes negative and then positive. All right. We then change the, we already changed the signs. We then combine like terms. Again, be careful, all right, to realize that after these two terms cancel, all three of these don't have a like term partner, do they? None of them combine with anything. These two cancel, but these three don't combine with anything, so we get this right here. Okay, they all need to come down separately because they don't combine with anything. All right, we're almost there. All right, remember the final, outside part right here is degree 2. This current remainder that we have is also degree 2. And so we just need to what? We just need to, it looks like, not for sure, but it looks like just one more round of dividing, multiplying, and subtracting is needed here. So 9x squared divided by 3x squared, the x squareds cancel and you get just plus 3, positive 3, so we say plus 3. Distribute that through. We get positive 9x squared, negative 3, but that's got to change to negative 9x squared plus 3, as we always do with the second line. Combine like terms, the 9x squareds cancel. The x doesn't combine with anything, but the 4 and the 3 do combine, and we get x plus 7. That is a degree 1 polynomial. Okay, and so we can stop now. Don't be alarmed, you guys, by the fact that this has more than one term. This is the first time we've had a final remainder that has more than one term in it, but don't be alarmed by that. That happens sometimes. Okay, just go ahead and do the normal thing here. Put the remainder on top. This thing that's on the outside, the divisor, that goes on the bottom as usual with a plus in front of that fraction. And then that's your answer right there. Okay, so that is long division. Okay, as usual, contact me with any questions or concerns. Have a good day.